In this next tutorial we will work again in TouchDesigner, and using the two techniques we learned in the previous tutorials, we're going to use Stable Diffusion to generate real-time graphics with artificial intelligence. Stable Diffusion is an open-source AI model that can be used through coding if you have programming knowledge. If you don't, there's a tool called Comfy UI, which is also a node-based system. It's a bit more complex because it requires some understanding of AI to get results, and the interface is also node-based but might feel overwhelming at first. It can also be used within TouchDesigner, which acts as an abstraction layer that can incorporate other libraries, like we saw with MediaPipe or with the custom components built to use the Kinect camera. In this case, to generate real-time content we're going to use String Diffusion, which is an adaptation or solution that uses Stable Diffusion for real-time graphics generation. Again, this can be used in any of the environments we've mentioned, either with code, as it's officially implemented using Python, with Comfy UI, or within TouchDesigner. For the latter, we're lucky that Simulate, a creator who builds libraries, components, and tutorials for artists, has created a .tox. As we discussed before, a .tox is a TouchDesigner file format for reusable components. Simulate offers access to these tools through their Patreon. This .tox handles all the complexity of using String Diffusion and Stable Diffusion in real time inside TouchDesigner. Although this sounds like an ad, their Patreon is just €5 a month and gives access to tons of cutting-edge content and very thorough tutorials. To get started, just follow the instructions to download it. You'll need to become a Patreon member, download the files, and once you've done that, you'll have a .tox file. You can import this .tox into your project, and the first thing you'll need to do is go to the Install tab. Clicking View Installation Guide will open step-by-step instructions. Basically, you choose a folder where everything needed will be installed, and click the buttons to install them. These AI tasks are very demanding on your graphics card, so the better your GPU or the more powerful your computer, the closer you'll get to true real-time performance. Ideally, that means 60 frames per second. 25 frames per second is about the minimum for smooth video. This only works with NVIDIA GPUs, it won't run on Macs or on machines with integrated graphics, as they're not powerful enough. Once the installation is done, go back to the Settings tab. There are lots of settings to explore. My server is already open, but once it's closed, or if you're starting fresh, all you need to do is drag the .tox into your TouchDesigner project. If it's your first time, go to the Install tab, click View Installation Guide, and follow the listed requirements. Choose a folder where everything will be installed and click the necessary buttons. Some are optional, most are required. Once installed, go to the Settings tab and click Start Stream. This opens a terminal that loads Stable Diffusion and String Diffusion. It will begin loading all the models. Then you'll see two input slots. The first one, although unnamed, is where you input the image you want to transform. For example, let's bring in our famous banana. Let's make it rotate, otherwise we can't really test this in real time. So we set abstime.seconds *50 and connect it to the first input. After connecting it, you'll see the prompt you want to apply to this image, for example, cat, and you'll see how it generates a cat based on what's happening. This text box isn't real-time, you can't just type and see updates immediately. So to do that, we'll add a text component, set its edit mode to continuous update, and enter cat. Then we drag the output from this text component into the prompt input and set it as a reference. Now we have real-time text control over what we want to generate. Right now we're feeding in a banana, but we could also use our webcam feed. Let's connect the front camera. At first, not much happens. Let's check. This image is relatively complex for AI transformation via Stable Diffusion. In the denoise schedule, the further forward we go, the more it resembles the input image. You can see it's AI generated because it's modifying my face. The more we reduce the denoising steps, the more influence the AI prompt has over the image. There are ways to balance this, giving the prompt more or less influence, while still letting us recognize ourselves in the generated image. First, we'll use what we learned in the MediaPipe tutorial. As mentioned before, we'll make it load externally to avoid heavy files. We generate what's known as OpenPose, another AI library used to feed pose data to AI. You'll see here that it's me, represented with colors OpenPose assigns to body parts for pose recognition. We'll add the same image used to generate this data and go to the Media Pipe tab to disable overlays so we get a clean image. We connect this to the first input. The second input, though unnamed, is meant to receive ControlNet data. If we go into the parameters of this component, there's a ControlNet tab currently set to off. We enable it, select OpenPose, and then restart the server so it downloads the necessary models to use Stable Diffusion with ControlNet. Once that's done, the AI will now generate results with ControlNet. ControlNet also has a slider that sets how much influence the reference image has. I'll keep the OpenPose model nearby for comparison. With OpenPose as the guide, the AI prefers to generate human-like figures because it's looking for poses. Let's try the prompt robot. You'll see the generated result reflects a robot-like shape. It might look layered due to reflections, but the anthropomorphic figure now makes sense. We could even try anime character and simulate dancing or movement, though this works best standing up, and I'm sitting right now. Still, you get the idea. This is one way to generate visuals. Let's reduce the setting slightly. The setting is currently at 1, you can experiment with different prompts. It's clear that anthropomorphic figures yield better results. Next, we'll use the depth cameras we looked at earlier, specifically, the Kinect. Again, this gives us depth information, which we can feed into a ControlNet model made for depth maps. First, we'll clean the image, like we've done before. We'll ensure it's mapped to the color image too, because that's what will be used later. We invert it with a level component so white becomes black. Then, we'll remap the image values using a math component. The more 0 to 1 information the model receives, the better its output. We clean the image again with a threshold to isolate just myself, and we use that as a mask. Again using the math component, we pass it as the mask image. The background is a constant, a fully transparent image. We tell it to use luminance instead of alpha and set it to 32-bit float RGBA to maintain a transparent background. We forgot to clean some of the background artifacts, so we go to Image Filters, use the Dilate component, and erode the image slightly to remove noise and update the mask. Now the resulting image looks much cleaner. We bring in the color image, unmapped, and set it as the input image. Back in the Depth tab, we confirm this is our source image, and the second input provides depth information. We restart the server because we're no longer using OpenPose, but a depth input instead. Once installed, we'll see the effect. Let's test with something less anthropomorphic, like thunderstorm. We feed in this image. We'll make sure it appears over a black background. The color image is the source, and the depth map is our second input. I inverted it because ControlNet expects the closer parts to be white, the opposite of the Kinect's output. What String Diffusion is doing now is transforming that image into a thunderstorm. If we input a less specific image with combined visual and depth info, we can use it for both inputs. This image gives the model information about my body and geometry. Using these techniques, we can generate much more interesting visuals. For example, I can become a lightning storm, or now I can become leaves that make sense, something that didn't work earlier, or I can even become a building. And that's all for today. See you next time.